Mike, for the introduction. I'll just share my screen and then we can go from there. So I hope you can all see my screen.
Yes, we can.
So thank you for the introduction and thank you all for joining this meeting today. And from the title of my talk, I will be speaking more or less about Open by Design. And I'll be talking about project planning from an open science perspective and what are some of the tools that you can use to practice open science while planning your project. And we'll be going through the whole research life cycle and how or which tools you can use within each stage of the research life cycle. How can you conduct an open and reproducible research? How can you practice open science through your research? And so that's what we'll be talking about today. And really, the approach that I will use in today's presentation would be more or less having an interactive conversation with you. And so you'll be getting a number of questions throughout that I would really be glad if you can give me some feedback. And so we will more or less be making this presentation together. We'll be talking about project planning together, covering the concepts of open science as we go along. So that's a common statement. If you fail to plan, you are really planning to fail, Benjamin Franklin. And so each of you, if you've gone through a research project, you've had to plan in one form or the other. You had to develop a research proposal. And through the previous sessions, the first day on open science, the second day on research data management, a number of concepts have been introduced, and tomorrow you will have another introduction to reproducibility and community building, and finally open source on Friday. And through this presentation, I just want us to, in one form or the other, bring some of these concepts together, but just covering them from the project planning perspective. So if you talk about open science and the need and the desire to ensure that you're conducting your research in an open manner, and by openness, we're talking about the embodiment and practicing those FAIR principles being within your project: findability, accessibility, interoperability, and reusability. And so there comes the first question here. And I'd like for you to just provide some responses to this. What comes to mind when you hear the statement project planning? And I'll just open up this poll for you, and we'll just, in the next 1 minute, I just want us to fill in that. So what you do is you go to www.menti.com and then use the code on the screen. So I'll just share this on the chat. That one. So you use that code, go to that link, and then use that code to just add your responses there. So please do that. We have 1 minute, and we'll be seeing as responses comes through. You can have a single word. It could be a sentence. It could, whatever you can share there to just be captured. So in 1 minute or so, let's fill that in. What comes to mind when you hear the statement project planning?
I put on the timer, Caleb. How many minutes?
1 minute.
1 minute. Okay. Just a moment. Okay, there you go.
So think about it. Your answer could be, why is it important? So could be, why do you need it? Mhm. So, uh, this is the feedback that we've received here. So systematic execution, a systematic approach, documentation, planning, organization, sustainability. So it looks like the predominant is organization, project planning. It's way to be really organized and ensure that everything can go as planned. You talk about budgeting, one of the things that would be required when it comes to project planning. And really, when you talk even about open science practices, you would really have to think about the budget there. So when it comes to project planning, it could be at the stage of, you want to write a proposal which would be submitted for funding, or you're writing a proposal submitted to your school for approval. And whatever the case, you need a budget. And if it's a submission to projects, more or less for funding, then budgeting for research data management would be really important. Budgeting for research dissemination, research output dissemination, including publishing there. You would really be also want to document your project. Timelines is really important, and really a plan without a timeline that's just ideas or just thoughts. And then you want to ensure your project is sustainable, really good. Organization seems to be the major one. Replicability. So you want to, as you plan your project, you want to ensure that the whole process is highly replicable and reproducible. Other people could use those terminologies, and I think tomorrow you'll get to see the distinction of those two. Methodical, the endpoint, thinking about the end, really important. A deadline linked to the timelines. What's the end goal? What's the end point? And through between the now and the end goal, what do you need to do? What are your strategies there in the middle there? And of course, in the end, you talk about also that's systematic. How can you ensure that you systematically execute your research? And those are really great output. And so that's really what mostly comes to mind. And so when it comes to developing, you're starting a new project, you have a number of things. And I've talked about that. We will be talking about these from two perspectives. We'll be talking about either you are applying for funding or for university approval. And so at the very beginning of your project, you'd be trying to identify the gaps, the aims. So reading through literature and being able to identify the gaps. So here, and the concept, I'll come back to that. So the concept that there are two things. You will always be applying open science or utilizing open science. So utilizing open science or generating open output. So if you look at it here, gaps, the aims and expectations from your research, you'd really have to utilize a body of knowledge that already been put out there. So if that body of knowledge is really openly accessible out there, you'd be utilizing those information to develop your project plan. So at this point, in addition to just reading literature, you'd also be utilizing data that's available freely to test your hypothesis so that you can be able to develop a robust proposal. And then you have your earliest version of the plan. What do I need to know to achieve my research goals? What kind of resources do I need as you plan for that? So the resources could be experimental materials, or it could be what kind of data, what kind of funding do I need for that? And then, of course, after all the plan you've developed, what are the appropriate funding sources to be able to execute this idea? Who can I reach out to? Where can I submit my proposal, my funding proposal to? And then now, an idea of the constraints and the bottlenecks. what could go wrong when it comes to execution of this idea. And then now, having done that, you have the earliest version of your plan, you want to create a project, a potential timeline. So most of you actually captured this really well, a potential timeline. And that's just at the very beginning. And then you have now, when you have all these well developed, then you have your project proposal for funding or university approval. So within the project proposal, the next question to you, to all of us, would be, what do you include in your project proposal? And then in the end, you have your project plan. So most of our conversation will be around project planning. So some of the main concepts as you develop that would be, you want to plan for how much time and money. So when we talked about resources, you have time, money, and other materials that you require for that project. So how much will it cost to publish your results and data such that it's freely available from the very beginning? So remember, you want to plan a project that is open, embodying the open science practices. So as for this cost in your grant proposal, and this is really important, there's the reason why you want to capture and you want to think about open by design and from the very beginning and through the whole research life cycle is to ensure that you can plan for any resource that you require. So funding, data, infrastructure, and so forth, that would enable you to disseminate your research openly, share your data, prepare your data for sharing, and so forth. So there's the aspect of publishing both your data and final results openly, and that the purpose of that is to increase trust. That's actually really science is all about trust. So provide a good documentation and metadata so that others may reuse, remix, and remix your data, which really the purpose of that is to increase your citation rate, increase the value of the data. So you want to enhance the value of your data, and the way to enhance the value of your data, yesterday we talked about, now as you share your data, you want to share your data with a permanent identifier and an ability to cite, and there are some of the platforms that can enable you to do that. But shared data that's available out there without documentation and metadata is not really reusable, right? Then there's a final concept here on pre-registering your research to avoid scooping. And I think some of the questions and discussions yesterday were around by sharing my data, by sharing my project early, I may end up being scooped. And some of us were seeing that as one of the concerns when it comes to working openly. But really, by pre-registering your research, you are setting claim that this is my work. I've thought about it, I'm thinking about it, I'm working on it, and I will be sharing my results soon. So some of those is just setting that precedent set, or setting that, putting the stamp that actually this is what I'm working on. And that will really in the end reduce or really avoid the scooping. So from the very beginning of your research process, the researcher both contributes to open science. You are the researcher. You both contribute to open science. The research that you're undertaking will be contributing to open science. But also you are taking advantage of open science practices of other members of the research community. And this is why the practice of open science is something that we all do as a community. We contribute to it, we take advantage of it. We benefit from open science, we contribute to open science. And really, as we talked about, when you talk about open science, really that's science. In the end, actually, what you want to get to a point whereby publishing in closed access or pay by to read access or closed access is something that is not the norm, because right now it seems to it's still kind of the norm, and there are barriers to that. But when you get to the point whereby everything is openly available, people are collaborating, people are not working in silos, then that would be the ideal. And so we contribute to and we take advantage of open science practices within the research community. And that's where now it's really important to plan to be open by design. So as you think about your project proposal, so let's think about it this way. Now you have submitted, if you're thinking about funding, you've gotten funding, and maybe you are working on a project proposal to your university, your project proposal for your project plan. Now, what do you always include in your project proposal? Think about your, either it's a PhD, postdoc, MSc, undergraduate research. What is always included in a project proposal? What do you always include there? So let's spend a minute and think about what's commonly. If you think even about your university template, what's always there? And do you think it's sufficient? What do you need to also think about when it comes to your project plan? Because the project proposal, you're just proposing, but when it comes to, you will in the end need a plan. That's where it's really important to think about the whole research life cycle. So let's go to this next page here. I said we will be doing this together. What are the key components of a project proposal? What do you always include in there? So feel free to enter as many as possible. It will always be ranking them and just visually displaying to us what's important. So I'll start the countdown now, and you can use the same, go to that code. Same one, but I've just moved to the next page. Okay, seconds. What are the key components? A few more. The background information, the methodology, we'll give us a few more. You have about seconds more to just think about this. We have methodology and literature review being the dominant. The duration, timeline, why project is vital, research impact. Now the voting is closed at this point. And now let's think about these concepts that we've captured here. You have the background of your project and just the basic understanding, the background information that would help someone understand really the various concepts within your project before you get to your literature review. And within this background, sometimes highlight the gaps and talk about now the objectives and everything, the objectives of the projects, and then get into the literature review, a review of all the work that has already been done. And so if you think about it here, you'll be using open access tools there. but you would have the methodology, which seems majority of us have captured that, then literature review, then methodology, and then you have your, maybe your research impact, then your budget and then the timeline. Okay, now if that's what you submit, that's your project proposal that you've submitted. Now the question is this sufficient as a project plan? Is your project proposal sufficient as a project plan? Would you be able now, using the project proposal, can you be able to have a clear plan of how to undertake your research project? Do you think it is sufficient as a project plan? So you can, on the chat, can say yes or no on the chat. Mhm. Is it sufficient? So a few of you, two of you have said no. Anyone else? Let's work with that. So we've said, nope, it's not sufficient. Now, the research life cycle, and really what you were talking about there, your whole project proposal. If you look at your project proposal and you map it on top of the research life cycle, and think about it, whether it is sufficient, you notice most of the time your research proposal is not entirely your research plan. You really have to take a step further and create a plan. Our timelines, mostly that Gantt chart is never as detailed. You just give a rough estimate within this number of months. This is what I'll probably be doing, but breaking it down into actionable items on a day-to-day, on a week-by-week basis, on a month-to-month basis, may not be provided by that research proposal. So when it comes to research life cycle, you have your hypothesis, and of course, if you are submitting for funding or you are submitting to the university, you'd consider your financial requirements or consider your university requirements and think about your hypothesis there. Then, with the hypothesis that you already have, and that's from your literature survey and research gaps and all that, then you develop an hypothesis and you go and collect data to test your hypothesis. And here, of course, you want to give credit where it's due. Now, processing of the data that you're collecting there, use open source software and interfaces. And we'll have a look in more detail a bit later on some of the open source software and interfaces that you can use to facilitate that. Then you've utilized some of this open source software. Then you have storing data and results. Make use of service infrastructure, attach persistent identifiers, descriptive metadata, publishing metadata in open license. And of course, thinking way in advance to long-term preservation. If you'll be generating data, how will you preserve that data? And that's why it's important to have that data management plan to facilitate the planning of all these and being able to resource, to prepare for, to plan for resources that you'd use for that. And then you have publication, and then you have reuse. So ensure that someone can actually, when they reuse your research material or research output, you can get credit out of that. So we've shown that that may not be, our research proposal may always not be sufficient. And it's really important to plan to be open by design as opposed to open by default. Open by default is just whatever comes, we'll work with what comes, we'll work with what's available. But when it comes to open by design, you are actually putting thought to the process, the tools, the resourcing that you require to be open. And that's really important. So This, I've shared a link there and I'll share the notes later on. There's a really, really nice book, Open by Design, and it captures most of this research life cycle from the ideation, more or less the ideation phase or provocation phase, all the way to preservation and storage and maintenance. So starting with the ideation here is to develop and revise the research plans. Now you already have your proposal and everything, but now you want to develop and revise your research plan and prepare to share your research results and tools under the FAIR principles. So you've already covered the FAIR principles: availability, accessibility, interoperability, and reusability. And here you want to test your hypothesis with existing data. You'll be using open data. Data management plan, our data, workflow, code generation will be shared. So what are some of the platforms that you can use as you plan for that you can use for sharing your data, sharing your workflows and the code? So if you think about the data, you have now various data storage platform for genomics. And I'll show you a single diagram that will cover all these workflows, code, and code as generated, or that will be shared. The next step, of course, knowledge generation. So you're collecting data, conducting research using tools that are compatible with open sharing. And using automated workflow tools to ensure accessibility of research outputs. So think about lab notebooks here. When it comes to lab notebooks, you could be dealing with, if you're working with software and code, you have literate programming tools. So you do have platforms like Jupyter Notebooks, R Markdown, and so forth. And these ones would be tools that allow you to properly document your research output as well. And then you have the validation stage. So you want to prepare data and tools for reproducibility and reuse and participate in replication studies. So here, at this point, when it comes to validation, in addition to just making presentations, so you'll be making presentations in conferences, sharing your preliminary data. And within this point, you want to get feedback from the scientific community. You want to get quick feedback from the scientific community, in addition to also just publishing preprints and even sometimes sharing advanced data. You want to get feedback and test for reusability and other people being able to just provide feedback and test the work that you've done. And then you do have dissemination. Now, having completed the whole research process, then you want to use appropriate licenses for sharing research outputs and being able to report all the results and supporting information. So here you're thinking about the data, the code, and the articles. So when it comes to data, you're thinking about open data, open source, and open access here. Then preservation, now long-term access to your research. If you are generating genomic data, where do you store your data in the end? If you are generating software, where will you store that software and ensure long-term access to that to those software? I can see our time is so much gone. So I just want to summarize by sharing now through the whole research life cycle. And now we can see some of these are the Open Science framework does a whole lot of brings together some of these, but I've really added tools that are specific to genomics, and you can think about it and bioinformatics around those areas. So if you're starting at the beginning here, search and discover when you're doing your research and you think about planning your projects, you want to use tools that allow you to now bring together and manage your literature for your literature survey. So you have Sotero and Mendeley, and those support that. But also there's PubMed, which also facilitate that. You would want to use when you're developing your idea to test your idea using data that's available publicly as well. So you want to go to NCBI, EBI, and some of these databases that are available. You have now, when you're designing your study, you have the data management plan. To develop a data management plan, you have the DMP tool. So the DMP tool would help you develop it's actually a series of questions that help you to answer when you answer those questions, you would have a complete data management plan. And all those questions are geared towards ensuring data reusability in the end, and planning for infrastructure, funding, and other resources that you would require to support that. So within the study design, acquire materials. Now there are several tools that you could use depending on which space that you are part of. Collecting the data. So you have a lot of survey tools. I could add RedCap here. I could add some other survey tools, open survey tools that you could utilize at that stage. You could be going to the field. You're acquiring samples. When you get the samples, how do you capture the metadata that you require for that? How can you use control ontologies that would ensure that the data that you're generating, the samples that you're generating, are reusable? And you can, someone else, when someone else comes to who wants to use your data, they can actually understand what you generated or what you gathered, collecting the data, and then now store the data. So you can see there's several tools available there. So you could be talking about the Google Drive box, Dropbox, OnCloud, or OneDrive. But also you could be, if you're collaborating with others, you could be storing your data in Amazon Web Services like the S3 buckets that would allow you to share your data with your colleagues and be able to collaborate. You could also share your data via more advanced tools like Singularity, via Docker and Singularity, which would allow now a higher level of reproducibility. The software that you're using, the data that you're generating, all packaged into one, and someone can actually reproduce the work that you've done. It comes to analyzing the data. You can analyze the data using several platforms. You have also the Amazon cloud now, the HPC in the cloud on Amazon, or an HPC, or it could be you're just on the command line using Bash, or you could be using Jupyter Notebook. So these are tools that would facilitate and support reproducibility. And the higher level of reproducibility is when you, in genomics especially, you are utilizing workflow languages, and that's where now you're seeing things like Nextflow. And you can see most of these tools, they are bringing together a variety of software. So if you look at Synapse, which is another platform that you can utilize, it brings together R code on the command line, Python, and on the web, and all these brought together to facilitate high-level reproducibility. So there's Nextflow as well. And then now, as you move further, you could be doing your write-up using the R Markdown, which can allow you to convert it to Word, PDF, to LaTeX, and several other dissemination platforms. Or you could write your research output using LaTeX, and LaTeX allows you to really properly version control your work. As you can see, there's Git and GitLab here as well. So that at the higher level, as you move through the research life cycle, you could now think about after writing the report, you have now disseminating your data. You have NCBI now, the SRA if you're submitting, or GenBank if you're submitting sequences. You have Zenodo to ensure your research have a permanent identifier and they are citable. Figshare is another platform, and Dryad is another platform. All these are some of the platforms in which you can submit your data for now reuse and just general sharing of your data. Okay, and now in the end, you can publish your results. And as you publish your results, you want to really publish in open access journals out there. And all these, through the whole research life cycle, you can practice open science if you just get to understand the various tools. And if you think about it, you already have an understanding and most of these components that facilitate openness and open science. And so it's all about getting to think and plan in such a way that you can utilize all these tools to facilitate that. So now, I just want to, as we just wind up, I just have two more questions. One is, which tools do you use to manage your projects? This is now project management aspect. Is what I've talked about is now all the various tools that facilitate open science. Now, how do you manage your projects? Which tools are you using? So there's a few more questions here. Which tools do you use to manage your project? So these are different links this time. Just add it to the chat. Which tools do you use to manage your data? And let me just open for voting. You just write on your paper. You utilize GitHub project management platform. You use notebooks, for example, the Evernote and so forth. So for example, myself, I use Evernote a whole lot for project planning and a whole lot of project management. And I also combine that with the GitHub projects. So what do you use to manage your projects? Really nice. Good chat. And Node, clear literature, citations. R. So I'll just keep it open. You can continue typing as we just have a look at and discuss some of this. So if you look at most of these tools that you've shared, Docker Singularity, GitHub, those are really, really, really good. And these are tools that you use for reproducibility most of the time. But if you think about it, you would need a way to bring all this together. So you could use GitHub now to capture or to bring most of this thing together. So if it comes to workflows, so SnakeMake for workflows, or someone else would use Docker Singularity and Nextflow to manage to ensure that that process is highly reproducible, their research process. When it comes to the next stage of the research lifecycle, then you can bring on board a different tool. So you would really have to use several different tools as you go along when it comes to your research. Okay, and then the next question there, since our time is quite gone and we should be done. So what's your take-home message? Could be a single statement, one word. So it's same link. Let's use that. We'll set you there. If you fail to plan, you plan to fail. Plan, plan, plan. Use open source for planning for easy execution. We'll keep it open as we complete. So if you look at it, really, it's important. In the end, it's all about planning. So, and here, Vincent, learning the project design cycle, documenting every bit of information, locked in late, but what I picked. Yeah, so that's what he did. So yes, that's it. It's really important to think about the plan from the word go. The failure to plan is what we call, if it's, oh yes, I'm an open science advocate and I would like to utilize open science in my work, but you don't plan for open science. If you don't plan, what you're doing is open by default, and really you'd get to the project publishing phase and you realize, in as much as you want to publish open access, when you wrote your proposal, you did not factor in the funding for article processing charge for publishing. And so that means you end up maybe going publishing in a closed access, which you do not need to pay for it. Of course, proper planning is essential for project success. Really good. Thank you for that. We need to plan before we begin. Yes, think about the yarn from the very beginning and be able to look at the whole research life cycle and think about what kind of tools do I need to use through each of these stages? And there's a general for any project plan. But now think about which domain are you part of? If you're in the life sciences, you spend more time in the wet lab. What kind of, if it's project research output dissemination, what can I use to make sure that I can also get recognition for my protocols and so forth? And so that's it from me on this. And thank you really for participating with me on this. And I'll just share 2 books on project planning and managing scientific research. And the other one is really open by design. Thank you.
Thank you, Caleb, for that wonderful talk today. Yeah, we cannot overemphasize the importance of project planning, as you start by saying, and I think everyone has caught this about if you fail to plan, you are planning to fail. And so this is really important. So I don't know if we take a 5 minutes break, or we can just go ahead and start the question and answer session. What do you think? Caleb, do we go ahead and have the questions right now, or we just
Are there questions already?
No, not at the moment. So maybe we give time people to think about it for like 5 minutes. Yeah. Let me just try and put the timer. Yeah. So yeah, 5 minutes, and then we'll be back at around, so it's 11:51, and so we'll be back here at around 11:56. Sorry, 11:56. Good. Yeah, please walk around, have some coffee, have some silver tea for those who can't get coffee. Walk around, stretch a bit, and we'll be back. Thanks. Still back? A thumbs up if you're back. Yeah, I get 2, 4, 6, 7. At least if I get 20, then we can start. I see one hand raised, Vincent. I'll note that. Awesome. And Caleb, is Caleb back? Yes, awesome. Thanks, Caleb, again for such an excellent presentation. And you've taken us through the journey of project planning, and actually even introduced tools like DMP that I really want to start utilizing it for my project planning, as well as mentioning about reproducibility in research, and that we should know that the research that we're doing every day, it's not for our own benefit, and for our team, but also for people out there, so that they can actually do the same analysis and get whatever we got for our publications, for example. And so all these that we've learned today, maybe I can start by a question. how do you connect? Now you have planned for your project and then connecting it to the timelines. You'd agree with me, sometimes we deal with supervisors who are overambitious, for example. And what do you comment on that? We already have a plan of what we're going to do, but again, the time might be limiting, or the time might be too much for us to, achieve the end goal that we've set. So maybe you can start with that, and then we can go Vincent, and then we can check out the chat.
Thank you for that question. I think that's a concern that comes up a whole lot when it comes to you already have a plan, and I would want to believe that that's a plan that you've agreed between yourself and your supervisor, and as you work towards execution of that plan, of course, as you said at the beginning, you have timelines, and you want to ensure that you are realistic in that plan. So by ensuring that your plan is realistic and time bound, you would allow you to actually deliver on it. But then now, as things come up that would maybe deviate, like allow you to deviate really greatly from the plan and would affect the timeline greatly, it's a discussion that you actually need to have. So, because one, the plan enables you to address some objectives, answer your more or less address your hypothesis and so forth. And so anything that comes up that doesn't meet these conditions, that doesn't address your objectives at the very beginning, you can have that nice discussion, if you can, with your supervisor on how that would affect. So it's really important to say, okay, yes, we can do this, but this is the effect it would have on the plan. Or if we do this, we may have to adjust this and this. It's really important to have that open conversation with your supervisor on the timelines, on how any addition would affect the timelines, and just being realistic or whatever you are proposing. And by doing that, you can all agree whether you would need to extend the timeline or whether you need to make changes to still allow you to complete your research within the timelines that you had set in advance.
Yeah, thanks for that. I think you brought it clearly that having an open discussion with your supervisor, because at times you find that we as students tend to want to impress our supervisors, but anyway, like communication is, real. So we go to Vincent. You can unmute yourself and ask your question, and then we can go next to Mike Mwanga. So Vincent, I think now you're able to unmute yourself. Are you there? All right. Mike Mwanga, would you want to unmute yourself and speak? Oh, yeah. Okay, your mic. Okay, thank you, Caleb, for the great talk. Please comment on how much room is available to deviate from the initial plan of the project. Say a new idea has come up and needs to be incorporated to the project and might alert the project to some extent, may alter, the project to some extent. Also comment on ethical requirements while planning for a project. That's a question from Mike Mwanga.
Thank you, Mike, for the question. It's quite a loaded question, if you may. So the first one is, and I think we had started answering that to some level, how much room is available to deviate from the plan. And I don't know how much they usually say, like, if you think something will take you a week, I need to remember how much exactly. You would need to increase that time by almost a third. Just addition to that, if you think it would take maybe a week, add an extra 2 days, and that will always allow you some cushioning to that. But I would say that if you add enough buffer to your plan, then that would allow you to, it would more or less, you're not as stringent. So if you are not planning for every single second, every time, and that means if anything comes in, you really do not have time to bring that on board. So if you have enough more or less buffer within your the plan, the timeline that you've set, then it would really allow you to still bring on board these new ideas. And that, of course, happens with a discussion with your with your supervisor. So when a new idea comes in and it would really push, help you have a more solid research, address your objectives in a more robust way, then really that's something that you really want to cover. And so by just putting there some buffer to your timelines, that will allow you to do that. So you can deviate as much as the time and resources allow you to. On the ethical requirements when planning for a project, I'm trying to have a look at where that fits. So it could, I don't know if you could just clarify, are you talking about it with regards to data sharing, the ethical requirements that come with that, ethical requirements that come with data collection and so forth? If you can clarify a little bit on that, that would really help.
Yeah, so let's wait. Perhaps he's texting that on chat.
Mm-hmm.
Yeah, in the sense of data collection.
Okay. So I know that most of the projects would require really that ethical approval from most of the institutional ethical review boards. And of course, also you are expected to abide by the national data protection laws. And I think when it comes to data collection, there's really that need. If you're working with data subjects, you're now the people you're going to interview, getting the data from. It's really important for them to really understand what you're doing. So the concept of informed consent, making sure that they fully understand the work that you're trying to do, the kind of data you're trying to collect, and what you're going to use them for. And as you do that, you want to abide by the ethical requirements within your institution and the kind of work that you're doing. And really, in the end, you want to ensure that the benefit goes back to the data subjects. And that means really going back to the data subjects and checking the results back. So what's your return? How do you return that information back to the data subjects after your research is done? Do you go back to them and send provide that information? This is what we found from the research. And remember, when you're doing research, you're not doing it in a vacuum. Everyone else would also still want to go to these data subjects to get information from them. So if you do not, there's the ethics of that. If you do not abide by that and make sure that they benefit and ensure that they can feel that they are part of the process, they're not just being used to get data and people are gone. They're not, but they are being involved in the research. And also being given information at the end of the research, they get to benefit from that. And so by abiding by those principles, anyone else who goes back to these data subjects, they can get a good reception because they know this research is really going to benefit them. But I've seen cases whereby when people now the moment you just appear in that institution, they're like, you guys are here again. I think we had gathered this data before and we never even received any benefit from that. So yes, in the end, you really have to treat the data subjects with respect. I hope I've answered your question.
Yeah, it says thank you. So I think that's handled well. Thank you. Let me check on the chat on the HackMD document. Still, there's no question. Maybe if we can maybe think about implementation, especially from your profile, Caleb, you're a lecturer in some of the universities, especially Pwani University, you've taught in JKUAT. Are they currently planned to be enforced where students can actually, especially masters and PhD students, especially in Kenya, can start, exercising this? And this, I think, already we have the proposal part, we have the reports, but is there something that is going on in the region that can actually make students start to practice some of the tools that you've mentioned?
Thank you, Mike, for that question. Policy-wise, I think there is not much with regards to that. I think the major requirements from most universities would be through the research proposal and timelines that are set there, and the regular project update presentations through the research. But in terms of specifying some of the details outside the higher level proposal writing, when it comes to now the methodology and data collection and the application of some of these tools, I don't think it may be possible. It's not feasible for that to be done, because remember, you're dealing with different kinds of research in the universities. And so what they can only do is provide a higher level guidance, and that's especially for within the proposal writing. So I do not think that's available beyond that.
Do you think that's adequate enough to, handle this topic, in your opinion?
Maybe not. And I think what may be required would be some regulation when it comes to supervision, and how the supervisors can guide the students to ensure that they can create all these proper timelines and utilizing the tools that would facilitate research reproducibility and reusability, data sharing, and so forth. So the really big problem is usually the fact that some of these things require an open science and open access policies within the institutions. And in most of these institutions, those policies really do not exist. And the fact that they do not exist, a plan is always anchored on a policy. And when a policy doesn't exist, it's really difficult for that to be done. And so one aspect would be setting up policies around open science, or more or less open access. So research data management policies around that would be expected. And those policies would guide the students when it comes to how do they choose where to publish, how do they choose where to share their data, what's their intellectual property, and so forth. So all those are really important when it comes to guiding the process. So when there's no policy, then it's really difficult to implement some of these practices. Yeah.
Great. Let's see if there's any question. There's one from Stephen. Do you want to unmute yourself? All right, so there's one question for you from Stephen. How do you handle issues of conflicts of interest in collaborative projects or research groups? Number one, before commencing the work. Number two, any that may arise in the lifetime of the project. And number three, during the publication's time.
Yeah, that's a really, really good question. Thanks, Stephen, for that question. Issues of conflict will always arise, and goes back to planning. Failing to plan is planning to fail. Now, most of the time, when it comes to collaborative project, there's really need for clarity on the roles and responsibilities. Who is doing what? Why are they contributing to the collaboration? Why are they part of this collaboration? What's their role? And when that's really, really clear that the role of each and every member of the collaboration is well defined at the very beginning of the collaborative process, then it's easier to manage conflict. When someone comes and goes beyond their responsibility or the mandate, then you can go back to the roles that were set in advance. So before commencing the work, it's really important to set that really clearly. So if you look at research proposals and funding proposals as they go out right now, you realize that they require, in addition to set data management plan, there's always a management, just general management. If it's a multi-PI or our collaborative plan, is what I'm actually talking about. So when there's a collaboration plan at the very beginning, then it's easier to include within that collaboration plan conflict resolution approaches. So when that is well defined, how do you resolve conflict when it comes to within that collaboration? When that is set within the project, then it's easier to handle conflict as it arises. So for example, when it comes to publication, getting to agree on a publication formula, I've seen in the HTA Bionet, getting to draw a chart and just your contribution, like a table. So in terms of design and so forth. So by having a look at your contribution, they can just automatically define what's your order of when it comes to your co-authorship position based on that. So that's actually really important, defining that way in advance. And we've done that also in our Open Science project, just using a formula to define the order of co-authorship. And when that is done, it's actually, there's a process to it. Then there won't be a conflict. But when it seems to be rewarding others and others are suffering based on someone just making unanimous decisions, then that doesn't work well.
Stephen, you can try and mute. Yeah, you wanted to speak. Please go ahead.
Thank you for that, Mike. And thank you, Caleb, for the good presentation and as well handy answer to my question. You kind of mentioned the order, which is interesting, and it's something I've seen in the H3 Bionet publication guidelines. However, I've also noted that most of the times, especially in papers related to, of course, genomics and bioinformatics, you'd find that the actual designers of the project, in terms of actual collection of samples, do not actually get to be the first or the second authors. Instead, they usually put at the back of the publication lineup. Would there be any reason why we would give priority to data analysts or bioinformaticians to be first authors in data that they contributed in analysis, but they actually did not maybe go out to the field to do this, or take part in the actual project or research design, or actually participate in seeking for grants to do the project? Thank you.
Thank you, Stephen. And I think when it comes to answering co-authorship order, there are a number of positions that are really important. There's always the first author, and there's always the senior author. The senior author is usually the person who provided the resources. So whether it's funding for the project, they wrote the proposal, they're the ones who had the idea. And then mostly the first author is the person who did the work. Okay. The last author is usually the person who had the conceptualization of the idea, and they usually provided resources to support or facilitate the undertaking of this project. And so the authorship would always be set in such a way that the senior author is always that person. The first author is the person. So first, second, as it goes, it's based on how much work you did. The last authorship is how much coming towards the middle. It's how much you contributed in terms of resources and the idea. So the senior most author would be the last author as it comes. The other author position, or more or less that would be important, is the corresponding author. So the corresponding author would also be another position that's actually important. So someone can be a senior author, they can also be a corresponding author. So when you're a corresponding author, that's a more also certain seniority assigned to that. And sometimes that is assigned to the first author or the last author, usually between the two. So how that is always chosen is based on that. So from the last position is your contribution in terms of idea and resourcing. From the first position is in terms of your contribution to actually undertaking the project, the execution of that project. So the day-to-day analysis, data gathering, and so forth is from the first going towards the middle.
Okay.
I hope that answers your question.
Yeah, that answers my question. So the last question, just before I give Gitao the floor, what happens in a normal research setting, especially in human research? You'd find that as a data analyst or a bioinformatician, you actually participate in not one but 3 or 4 projects. How then do you strike a balance between all these projects to ensure that you actually give your best? And this is a personal question to you, Kibet, given your experience.
Yeah, that's the concept of taking what you can, what you can chew, biting what you can chew, I think. Yeah, that's actually a real concern. And especially at the beginning of your careers, we start our careers, there's always a tendency to say yes to any responsibility and project that comes on board. And you really, what you want to do is you want to get as much experience as possible. And it gets to a point where, and actually it's something I'm trying to learn, how to say no to additional responsibilities. And that really, what it goes back to, it goes back to defining really clearly your vision and your interests. So when you have a clear vision where you want to go, you know what kind of skills do I want to acquire? What kind of the general research, like your general research interest. So if you say, I'm interested in mentorship, I'm interested in capacity building, I'm interested in research within this specific domain. Okay, so for example, and maybe like open science around that. So anything that comes on board that doesn't utilize or doesn't allow me to grow or gain skills within those areas of interest within my vision and my career goals, then I would have to say no to that. And so it's really important to define that and be able to now figure out when do you say no. So it's based on that, and also based on, do I have enough time to do it? And that goes back to really well when you have a clear plan there, just being able to figure out whether you can undertake it or not. But it gets tricky because sometimes the roles and responsibilities that are added are from people you cannot say no to. And that's that gets a bit tricky. So I don't know if I have a really good answer to that. But I would say, in my opinion, what I'm doing or what I'm trying to do is anything aligned to my vision and anything that I have time for. So one, if it fails the vision, even if I have time for it, it doesn't get added to my plate. But even if it's within my vision and I don't have time for it, then it doesn't also get added to my plate.
Thanks for those responses.
Thanks. Joshua, John, sorry. Would you like to speak, or I can? Yeah, you're on mute. Go ahead.
Yeah. Thank you, Dr. Caleb, for the wonderful presentation and the questions you have responded to. So my question is quite of a follow-up to what Stephen asked. So in a situation or a scenario where you're having like different supervisors, and especially at such times when like they are in different locations, so like we work based on comments provided on the write-ups that we provide. So sometimes we find that they might provide like conflicting information, or in terms of what you're supposed to work on, either if it's a methodical process or it's a revision of something. So what is the best way to approach this such that you, for lack of a better word, you don't rub shoulders with either?
Thank you for that question. I would answer it this way. So you have multiple supervisors and they're giving conflicting, sometimes they have difference in opinions or approach. So one approach is to figure out how you can, whatever is really aligned to what you had all agreed at the very beginning. But the best approach is to, when you have received comments and feedback from all your supervisors, request for a meeting to discuss some of those items. So especially when they are all in the meeting, in that one meeting, then you can be able to bring on board the various points and see how do we go about this particular item. Okay, we have this. I'm conflicted to this particular approach. I would like to get your consensus and your feedback on this, because you cannot really implement all of them if they are conflicting. Sometimes you may decide to choose one, but if you decide to choose one on your own, you would be the next time the other person will be coming to you and saying you did not actually follow my approach. And how do you judge which one is the right approach dealing with your supervisors? And I think the most important thing is to actually bring them on board in a single meeting and then have a discussion, all of you, and be able to come up with a consensus.
I
Thank you.
totally
That's
agree with you, Caleb. Yeah, especially when you have meetings with all your supervisors and they know exactly what is, happening. Awesome. It's good to see people commenting, and I can read a few comments from Margaret and Mike. Just to add on to that, it is paramount to always lay down duties and responsibilities of each individuals in a collaborative project in the initial stages. Also highlight who takes lead on which aspect of the project, and those will be first authors, else lots of conflicts will come, later. And also Margaret agrees on that by saying that having a vision and sticking by it will save us time, as well as saves people from burning out and, getting thrown around. Interesting. This feels like personal comments and experiences. Yeah, I don't know if we have any other question. Yeah, thanks for the emoji, Mike. Yeah, we learn from mistakes, our mistakes. Yes, true, very true. Every day, it's a learning process. Yeah, so I guess we don't have, let me check the HackMD documents. Still no questions there. So maybe as we conclude these sessions today, to you, Caleb, just to give us, like, I don't know, just an advice or just a last, thoughts about whatever we've discussed, I know we had a session where we had our take homes, but just clearly giving us a summary of everything that we've discussed. And I really enjoy your talks every time you speak to us. So just to give us a summary, and then we give Pauline Karega to give a vote of thanks for this meeting, and then we can close. And thanks very much for being interactive today and staying till the end of the meeting. I think that's going to be the last thing I say. Thank you very much, guys.
Thank you, Mike. So I think I'll say that have a design. So do things by design and not by default. And you can see the conversation has gone all the way to when it comes to your career, when it comes to managing conflicts, when it comes to managing additional responsibilities and so forth. And it's really, really important to think about the whole research life cycle and think about the issues that may arise, think about your timeline, and think about what you would utilize through the whole timeline. And when you think about those things in advance and plan for them, resource for them, plan for how you manage the conflict, plan for how you would share your data and so forth, you can be able to foresee some of the things that the issues that may arise, and by doing that you can be able to plan for mitigation approaches when those arise. So really do things by design, not by default. I think would be my final thought. Thank you for your time. It's been really a pleasure having a conversation around this topic.
Awesome. I see there's one question. I don't know if from Joki. That should be the last one, right? Or we just end the session? I don't know. Maybe just
a quick response to it. So I'd use this up. I'd answer it this way: a master's or a PhD. A master's is you learning how to do research. a PhD, you are contributing to knowledge within the scientific field. It's based on that. So you can contribute to knowledge you would contribute to knowledge when you're doing your research at the MSc level. But the core take home is for you to learn how to do research. How do you conceptualize? And you'd realize that you get more guidance when you're doing your master's, as opposed to when you're doing your PhD now. Your focus is more towards contributing to the scientific knowledge that's in the field. So the complexity may not complex. Of course, it's a given that complexity will increase based on what you're trying to do and the timeline that would be expected. But really, the main idea there is contribution to knowledge or learning how to conduct research.
Yeah, thanks. Over to you, Karega.
So let me just stop the recording.